All right, in this section, we're going to use the quadratic formula to solve equations. In the last section, we factored and we set it equal to 0, but not everything factors. Some equations are what we call prime. You can't factor them, and when you can't factor them, you have to use the quadratic equation, okay, or the quadratic formula, sorry. So the quadratic formula, before you set it up, you want to get everything equal to 0. So you want to have your x squared, your x, your whole number, and your equals 0. Now the number in front of your x squared is your a, the number in front of your x is your b, and the number that's left by itself is your c. Then you're going to plug them into this equation that you should memorize because this one is used often in mathematics. We're going to have negative b plus or minus square root of b squared minus 4ac over 2a. That's the equation we're going to use. So let's try one. We have 2x squared plus 9x minus 5 equals 0. Now the first thing I normally do is try and factor it, but I want to show you guys how to use quadratic formulas, so we're not going to even try, okay? We're going to say a is equal to 2, b is equal to 9, and c is equal to negative 5, and we're going to plug that into the quadratic formula. So negative b, well, if b was 9, that would make that negative 9, plus or minus b squared, so that'd be 9 squared, minus 4 times a times c. So that's 4 times 2 times negative 5, and all of that is over 2 times whatever your a is. Okay, so from here to here, remember exponents go first, 9 squared is 81, then you do your multiplication and division from left to right. So when you multiply negative 4 times 2 times negative 5 here, you get a positive 40. And on bottom, we had a 2 times 2. They had a typo, so I put that times 2 in there, which is 4. Now, 81 plus 40 gives me a square root of 121. Now, if you plug this in a calculator, or if you know this one, square root of 121 is 11. So this one is kind of interesting. We end up with negative 9 plus or minus 11 over 4. Now, you know what? When you are left with no radicals and no imaginaries, which we don't deal with in this class, but they do in college algebra, when we're left with no radicals, what that tells me is this would have factored. I could have factored that equation. So here's what we do when we get to that and we have no radicals left. We separate it. So we do, if you look right here, notice how there's a plus and a minus. First, we're going to do negative 9 plus 11 over 4. Then we're going to do negative 9 minus 11 over 4. Negative 9 plus 11 is 2, and 2 over 4 is 1/2. So this is one of my solutions right here. Negative 9 minus 11 is negative 20. Negative 20 divided by 4 is negative 5. So I have two solutions. It doesn't really matter what order you put them in, but those are your two solutions, and they will put those in brackets. Now, if you were to plug these back into the original equation, they would make it 0, so you can check your answer. These are also, as we noticed in the last section, if you were looking at a graph, these would be the x-intercepts.